So we have a mean of 254. So that is, suppose the distance of fly balls is normally distributed with a mean of 254 and a standard deviation of 60. We randomly sample 49 balls, so n equals 49. What is the probability that the 49 balls traveled an average of less than 242? Because we're talking about finding the probability about an average, we're going to use standard error. Standard error is sigma over square root n. Sigma is 60. Square root n is square root of 49. 60 divided by square root 49 gives you 8.57142857. And then to answer this problem, 3 steps. So the first step, put the average in the middle, 254. 242 is here, and we want the probability that it traveled less than 242, so we're going to shade this way. The second step is we're going to find the z-score. Z equals x bar minus mean over standard error. Your x bar is 242, your mean is 254, and your standard error is 8.57143. When we put this in our calculator, 242 minus 254 gives us negative 12, then divide it by 8.57143, and we get the z-score is negative 1.399, which rounds to negative 1.40. That's a z-score right here, which does make sense. It's below 0. And then you go to your normal table and look for a z-score of negative 1.4. Negative 1.40, we need negative. I initially thought it was this one, but this is way too large. If you look at the shading, I realized because our z-score is negative. So here's negative 1.40, which is 0.0808. So 0.0808, which it does look like 8%. Now the second part of the question, it's saying find the 70th percentile. So to find the 70th percentile, the first step is to graph it. The 70th percentile, when you shade it, you're shading 70% of the normal curve, so 0.70. And then we go to our normal table and we're looking for 0.70. 0.70 is right here, either these two. I'm going to use this one. That corresponds to a z-score of 0.5012, so 0.52. So my z is 0.52. That's the second step, was to go to the chart. The third step is now to use z equals x bar minus mean over standard error. Now your z is 0.52. X bar is what you're looking for. Your mean is 254 and your standard error is 8.571428. And so to solve this, you're going to multiply by 8.571428 to both sides. And these cancel out. 8.571428 times 0.52 in the calculator gives us 4.45714 equals x bar minus 254, and then you add 254 to both sides, and you get that x bar equals 258.457, so 258.46.